Imagine the American dream idling at a gas station that is run dry. The year is 1973, and the golden age of post-war excess has just hit a concrete wall. For decades, the philosophy of American industry was simple: bigger is better, and power was the only solution. On the silver rails that crisscrossed the continent, this philosophy manifested as massive, six-axle titans, locomotives with names that sounded like heavy artillery, and fuel appetites that would make a battleship blush. But then, the world changed. OPEC oil embargo did not just cause lines at the pump, it sent a seismic shock through the very backbone of the nation's infrastructure. Fuel prices did not just rise, they quadrupled, skyrocketing from roughly 12 cents to over 50 cents a gallon in a matter of months. For the great American railroads, companies that measured their success by the ton-mile, this was not just an inconvenience, it was an existential threat. In the midst of this chaos, a hero emerged, but it did not look like a hero. It was not sleek, it was not futuristic, and it certainly was not pretty. To the aesthetic purists and the high-horsepower junkies in the boardrooms of the Penn Central and the Rock Island, it was an embarrassment. Critics called it a lunchbox with wheels. They mocked its boxy utilitarian hood and its squat four-axle stance. To the critics, it was a refrigerator on wheels, a low-horsepower relic that had no place in the high-speed future of freight. They were wrong. That lunchbox did not just survive the crisis, it saved the American railroad from total collapse. This is the story of the EMD GP series, the misunderstood giant of the energy crisis, and how a machine built for utility silenced every hater by doing the one thing the superpowers could not do, keeping the nation moving when the fuel ran dry. The era of the guzzlers. To understand why the GP, the general-purpose locomotive, was so hated, you have to understand the era of the Super Series. In the late 1960s, the race for horsepower was at its peak. The big railroads were obsessed with speed and sheer hauling capacity. If a locomotive did not have 3,600 horsepower and 6 massive traction motors, it was seen as a yard toy, a machine relegated to the dusty branch lines of the Midwest. The kings of the hill were machines like the EMD SD45. These were the Ferraris of the freight world, boasting 20-cylinder engines that roared with a primal, terrifying power. They were magnificent, but they had a fatal flaw: they were thirsty. An SD45 under full load was a fuel-burning furnace. In an era where diesel was cheaper than water, nobody cared. Efficiency was a secondary concern to getting there first. Railroads were locked in a cycle of high-speed competition. They built massive, expensive locomotives to pull heavy trains at 70 miles per hour. But by 1973, the math of the American railroad was broken. Major carriers were already facing bankruptcy due to mismanagement and crushing regulation. The Penn Central, the largest corporation in the world at the time to file for Chapter 11, was bleeding cash. When the oil embargo hit, the cost of operating those 20-cylinder beasts became a death sentence. Suddenly, those beautiful high-horsepower locomotives were not assets. They were anchors, dragging the industry to the bottom of the ocean. While the industry was chasing the 4,000-horsepower dream, the engineers at Electromotive Division had been refining something much humbler. The GP series, specifically GP7, GP9, and eventually the legendary GP38-2, was designed with a hood unit configuration. Unlike the sleek cab units of the 1940s, the GP had a narrow engine housing with walkways on the outside. This allowed mechanics to access the engine without taking the whole locomotive apart. It was built for work, not for the cover of a magazine. Its four-axle design meant it had less weight on drivers than the big six-axle units, and its 16-cylinder 645 engine produced a mere 2,000 horsepower. To the executives who wanted to move 100 cars of coal at breakneck speeds, the GP38-2 looked like a toy. It looked like a lunchbox left on the tracks by a forgotten worker. The critics were vocal. It is underpowered, they said. It is a step backward, they claimed. They argued that you would need twice as many GP units to do the work of a single superpower locomotive, leading to more maintenance and higher crew costs. But Boris and the engineers at EMD knew something the critics did not. They understood the physics of the ton-mile and the coming reality of the American economy. They were not building a sprinter, they were building a survivor. When the fuel crisis hit its peak in 1974 and 1975, the railroads were forced to do something they had avoided for decades. They had to actually measure their efficiency. The results were a shock to the system. The Lunchbox, the GP38-2, wasn't just slightly better, it was a revelation. While an SD45 or a competing Alco unit was burning through fuel at an alarming rate just to keep its massive cylinders firing, the GP38-2 was a model of restraint. Data from the Association of American Railroads, AAR, began to paint a grim picture for the high horsepower fans. In heavy freight service, the big engines were averaging nearly 0.5 to 0.6 gallons per ton-mile. In contrast, the derided GP units were clocking in at 0.3 gallons per ton-mile. That is a 40% reduction in fuel consumption. In a world where fuel costs had jumped 400%, a 40% saving wasn't just good business, it was the difference between a profitable quarter and a bankruptcy filing. The secret was the multiple unit operation. Critics were right that a single GP unit could not pull a mile-long coal train, but the GP units were designed to be linked together like Lego blocks. A railroad could string 4 lunchboxes together, creating an 8,000 horsepower powerhouse for steep grades. Then the trick, once the train reached level ground, the engineer could shut down 2 of the units. The big 6-axle guzzlers could not do that. You were either running a 20-cylinder monster at full tilt, or you were wasting fuel. The GP series offered modular power. It was the first time the industry saw that less is more was the key to surviving a resource-scarce world. As the 1970s ground on, the railroads that had mocked the GP series were now lining up at EMD's door in LaGrange, Illinois, with their checkbooks out. The Rock Island, the Milwaukee Road, and the Erie Lackawanna were all staring into the abyss of insolvency. They didn't need pretty, they didn't need fast. They needed a reliable machine that would start every morning in a Midwest blizzard and move freight without eating every cent of profit in diesel fuel. The Lunchbox proved to be the most reliable locomotive ever built. The GP38-2 introduced -2 electronics, a modular solid-state system that replaced the rat's nest of wires found in older locomotives. If a circuit board failed, you did not spend 3 days diagnosing the problem. You swapped the board in 5 minutes and sent the Lunchbox back to work. Operating cost savings were staggering. Beyond the fuel, the maintenance costs of the GP units were roughly $5,000 to $7,000 lower per year than their 6-axle counterparts. In an industry where a single railroad might own 500 locomotives, we are talking about millions of dollars saved every year just by switching to the ugly design. Executives who had once called the GP a branch line weakling were now singing its praises in the press. One Union Pacific official famously noted that while their big units were in the shop, the lunchboxes were the only things keeping the grain moving to the ports. The machine that was supposed to eliminate rail freight with its lack of power was, in fact, the only thing keeping the heart of the American economy beating. The true test of the GP's legacy came in 1980. The industry was at a breaking point. Penn Central had collapsed and the government had to step in to create Conrail. The deregulation of the railroads via the Staggers Act meant that for the first time in a century, railroads could compete on price and efficiency rather than being shackled by rigid government rates. In this new survival of the fittest environment, the GP series became the ultimate weapon. The railroads that survived the 1980s, Norfolk Southern, CSX, and Burlington Northern, did so on the backs of the 4-axle workhorse. The beautiful locomotives of the 1960s were sold for scrap or relegated to secondary service. The SD45s, for all their power and glory, were stripped of their 20-cylinder engines and rebuilt with 16-cylinder engines, essentially turning them into larger, heavier versions of the lunchboxes they were supposed to replace. By the mid-1980s, the sales numbers told the final story. The GP38-2 and its siblings became some of the best-selling locomotives in history. Over 2,200 units of the GP38-2 alone were built. It was not just a general-purpose locomotive, it was the standard by which industrial efficiency was measured. If you go to a rail yard today, 50 years after the oil embargo first shook the world, you will see something remarkable. You will not see many of the superpower locomotives from the early 70s. They are long gone, victims of their own inefficiency and complexity. You will see the Lunchbox, the GP38-2 and the GP40 are still out there. They are the immortals of the rail world. They have been rebuilt, repainted, and repurposed, but their core, the rugged, simple, fuel-sipping heart, remains the same. They are still hauling grain in Kansas, moving coal in West Virginia, and switching cars in the industrial heartland of Chicago. They silenced the critics not with a roar, but with a steady, reliable hum. They proved that in the face of a national crisis, the flashy, the expensive, and the prestigious are the first things to fail. What survives is the machine built with grit, the machine built for the human being who has to fix it, and the machine that understands that every drop of fuel is a precious resource. The Lunchbox with wheels did not just save the railroads from a fuel crisis, it redefined what American engineering could be. It shifted the focus from how much power can we make to how much work can we do with what we have. It was a lesson in humility for an industry that desperately needed it. So the next time you see a boxy, squat locomotive idling at a crossing, do not be fooled by its simple appearance. Do not look at it as an ugly relic. Look at it as the machine that stood between the American economy and total darkness. It is a testament to the fact that sometimes the most underestimated tool in the shed is the one that actually builds the nation. The story of the GP series is not just about trains, it is about a mindset. It is about recognizing that the haters and the critics are often blinded by the flashy and the new. They ignore the lunchboxes of the world because they do not look like the future. But as the 1970s proved, the future does not belong to the loudest or the hungriest. It belongs to the most efficient. It belongs to the machine that can do more with less. Every time you choose reliability over flash or efficiency over ego, you are channeling the spirit of the Lunchbox. You are choosing to be the workhorse that survives when the thoroughbreds stumble. The American ironworks are not just made of steel and diesel, they are made of the wisdom to know the difference between a superpower that looks good on paper and a lunchbox that gets the job done. Explore the history of these misunderstood giants. Some lessons in engineering are learned in the laboratory, but the most important ones, the ones that save nations, are learned in the heat of a crisis, on the back of a machine that everyone said would fail. The Lunchbox is still out there, working, long after its critics have been forgotten, and that is the greatest triumph of all.